Welcome to G Fun Facts Online. When you picture a volcano, you probably see a mountain of fire and fury, a deafening roar, and an ash cloud blotting out the sun. That's the Hollywood version, and for volcanoes like Mount St. Helens, it's terrifyingly accurate. But what if I told you some of the planet's most active volcanoes don't roar? They whisper. They can awaken and erupt with little to no warning, releasing vast seas of molten rock and toxic gas while our detectors remain eerily quiet. Today we journey into the fascinating and unnerving world of these silent giants, unmasking the science of stealth eruptions. To understand what makes an eruption silent, we first need to appreciate that volcanoes have two fundamentally different personalities. This split personality is all about the magma feeding them, specifically how thick it is and how gassy it is. Let's start with the explosive type. This is your classic movie volcano. It's fed by magma that is highly viscous, meaning it's thick, sticky, and doesn't flow easily. This thickness is usually due to a high content of silica. Think of it like honey or even peanut butter. This sticky magma is also loaded with dissolved gases, mostly water vapor and carbon dioxide. As this thick, gassy magma rises, the pressure drops, and the dissolved gases start to form bubbles, just like opening a can of soda. But because the magma is so viscous, the bubbles can't escape. They get trapped, and they expand, building up tremendous pressure. It's like a pressure cooker on the verge of catastrophic failure. When the pressure finally overcomes the strength of the rock above, the result is a violent, explosive eruption. The magma shatters into trillions of tiny fragments of rock and glass, creating towering ash clouds and superheated, fast-moving pyroclastic flows. Now let's look at the other personality, the effusive eruption. This is the gentle oozer. Effusive eruptions happen when the magma has a low viscosity. It's runny, more like warm olive oil than honey. This is typical for basaltic magmas, which are low in silica. Because this magma is so fluid, gas bubbles can escape easily as it rises. There's no pressure cooker effect. Without that immense pressure buildup, the magma doesn't fragment. Instead, it pours out onto the surface as lava flows. These flows can travel for miles, gradually building up the wide, gently sloping mountains we call shield volcanoes, like the ones in Hawaii. While they're not explosive, they can still be spectacular, creating dazzling fire fountains that shoot molten rock hundreds of feet into the air. It's within this realm of effusive, oozing eruptions that we find the most mysterious silent giants. So if effusive eruptions are already the quiet type, why are some so quiet they offer no warning at all? The defining feature of a stealth eruption is the absence of the classic warning signs volcanologists rely on. Normally, when magma moves underground, it cracks the rock around it, generating swarms of small earthquakes. It also inflates the ground above, causing the surface to bulge. These tremors and deformations are the cornerstones of volcano forecasting. So how can a volcano erupt without making a sound or flexing its muscles? Recent research, especially from a mysterious, ice-clad giant in Alaska called Mount Veniaminoff, has given us the recipe. Veniaminoff has erupted 13 times since 1993, but only 2 of those events gave scientists enough warning to issue an alert. A 2021 eruption wasn't even detected until 3 days after it began. By creating complex models of this volcano, scientists have identified 4 critical ingredients for a stealth eruption. First, a slow magma supply rate. Imagine filling a balloon. If you blast it with a powerful compressor, the balloon's skin stretches violently. But if you fill it very slowly, it expands gradually. It's the same with a magma chamber. A slow, steady trickle of new magma allows the volcanic system to accommodate the extra volume without the violent rupturing that creates a lot of earthquake noise. Second, a modest-sized magma chamber. A huge magma chamber needs a massive influx of new magma to pressurize it, a process that's more likely to cause ground deformation that we can detect. Smaller chambers can be filled to their eruptive capacity, with less magma, generating much more subtle and potentially undetectable changes on the surface. Third, and this is a fascinating one, the thermal state of the crust. If a volcano has been active for a long time, the rock surrounding its magma chamber gets heated up. This makes the host rock more pliable and ductile, more like warm putty than brittle rock. When the magma chamber pressurizes, this warm, soft rock deforms and stretches, instead of fracturing and causing earthquakes. The volcano is essentially thermally primed to muffle its own sounds. And fourth, the magma chamber's geometry. The shape and depth of the chamber matter. For example, a large, flat, pancake-shaped chamber might cause very widespread but subtle uplift that's hard to spot with ground-based instruments. The combination of these four factors, a slow supply, a small and warm reservoir, and a specific chamber shape, creates the perfect conditions for a stealth eruption. The volcano can be primed and ready to go, yet appear deceptively calm to our monitoring networks. So what do these silent activities actually look like? The most obvious manifestation is the effusive lava flow. These rivers of molten rock are typically low-viscosity basalt that can travel great distances. The surface of these flows can take on two main forms, known by their Hawaiian names. There's pahoehoe, which has a smooth, billowy, or rope-like surface. This forms when very fluid lava flows slowly, allowing a flexible skin to develop. Then there is a guinea, a V, which has a rough, jagged, clinkery surface. This forms when the lava is a bit more viscous or moving faster, causing its brittle crust to break into sharp fragments. While most lava flows move slowly enough for people to get out of the way, they are relentless. They will bury homes, roads, and farmland under meters of solid rock. A key feature of these flows is the lava tube. This happens when the outer surface of a lava flow cools and hardens, creating a solid roof over a river of molten rock. These tubes are incredibly efficient, insulated pipelines that allow lava to travel for many kilometers with very little heat loss, as we saw in the destructive 2018 Kilauea eruption in Hawaii. But not all silent activity involves lava. Many volcanoes, even when they seem dormant, are constantly releasing volcanic gases into the atmosphere in a process called passive degassing. This silent exhalation happens when gases escape from magma deep underground through a network of cracks and fissures, without any molten rock reaching the surface. The gas itself tells a story. The most common gas is harmless water vapor, but volcanoes also release carbon dioxide, which is colorless, odorless, and can suffocate you in high concentrations. They release sulfur dioxide, the main cause of volcanic smog, or VOG, and they release other toxic gases like hydrogen sulfide and hydrogen halides. This continuous, quiet release of gas is a form of silent volcanism with its own unique hazards. The scientific detective work on silent eruptions is built on studying volcanoes that have caught us by surprise. The case of Telica volcano in Nicaragua is particularly fascinating. Telica is normally a very noisy volcano, constantly rumbling and puffing gas. But a 2016 study revealed something paradoxical. Periods of unusual seismic quiet were the most reliable precursor to an explosion. Researchers found that the volcano's vents were getting sealed off, likely by minerals precipitating out of the gas. This blockage caused pressure to build up, leading to an eventual explosion, and they found a direct correlation. The longer the silence, the bigger the subsequent bang. It was a literal calm before the storm, where the absence of a normal signal was the most critical warning sign of all. Given how deceptive these volcanoes can be, how can we possibly monitor them? The answer is a multi-pronged approach, combining tried-and-true methods with cutting-edge technology. The traditional toolkit includes a network of seismometers to listen for earthquakes and volcanic tremor. We use ground deformation monitors like supersensitive tiltmeters and GPS receivers that can track the ground swelling by millimeters. And we use satellites. A technique called INSAR can create detailed maps of ground deformation over huge areas from space, allowing us to spot subtle changes that might be missed on the ground. We also monitor gases, looking for changes in the amount and type of gas being released, which can signal that new magma is on the move. But to unmask the truly stealthy volcanoes, we're developing new tools. We're now using infrasound sensors to listen for low-frequency sound waves that are inaudible to the human ear but can travel great distances from a volcano. Then there's muon tomography. This is straight out of science fiction. It uses naturally occurring subatomic particles called muons, created when cosmic rays hit our atmosphere, to essentially create a CAT scan of a volcano's interior. By measuring how many muons pass through the volcano, scientists can map out its density, potentially revealing the location of magma chambers. We're also using lasers for near real-time chemical analysis of erupted lava, and employing artificial intelligence and machine learning to analyze the vast streams of data from our monitoring networks, helping us spot complex patterns that might herald an eruption. While they lack the drama of an explosive blast, these quiet eruptions are not harmless. Lava flows are an inexorable threat, unstoppable and capable of burying entire communities. But one of the most insidious hazards is volcanic smog, or VOG. VOG forms when sulfur dioxide gas reacts with oxygen, moisture, and sunlight. The result is a hazy mix of gas and tiny acidic particles that can penetrate deep into your lungs, aggravating asthma and causing a host of respiratory problems. It also creates acid rain that can damage crops and contaminate water supplies. Beyond VOG, the direct release of gases is a silent killer. Carbon dioxide is heavier than air and can pool in low-lying areas. Since it's odorless, it can cause asphyxiation without any warning. The 1986 disaster at Lake Nyos in Cameroon, where a sudden release of CO2 from the volcanic lake suffocated over 1,700 people, is a tragic reminder of this hidden danger. Living with these silent giants is a profound challenge. It requires a combination of better science, public education, and smart planning. We need to keep investing in research and advanced monitoring to better understand the mechanisms of these eruptions. And it's crucial that communities living near these volcanoes understand that a lack of shaking and rumbling doesn't necessarily mean they are safe. The image of the roaring, explosive volcano will always command our respect. But the silent eruptors, the stealthy giants that creep and degaw their way into our world, are no less formidable. They are a stark reminder that the Earth's most powerful forces don't always announce themselves with a bang. By continuing to listen for the faintest whispers of these silent giants, by respecting the power that lies within their quietude, we can learn to live more safely in the shadow of the volcano, whether it chooses to roar or to whisper.